Okay, we're going to talk and learn how to count atoms in a compound. First thing we'll do, most of the time, if you have a polyatomic, you want to split that out so that you can see the polyatomic. So this is going to be where we're going to split this. Whoa, that's really big. Let me try to fix that. Sorry about that. So we're going to split this here because here's our polyatomic. So what we're going to say is this has Cu and NO3. One Cu and one NO3 group. Now we also could break this down. Actually, we'll talk about that in a minute. We'll come back and do that next. So here we're going to split this. We have Cr and we have SO4. Those are our two pieces, right? We have a mono and a poly. This is mono, this is poly. This 2 tells me I have 2 CRs, and this 3 says I have 3 of this unit. Up here there was no parentheses. That's why there was only one NO3. Okay, so this one we have Ca and P, both of them are mono. We have 3 calciums and 2 phosphorus. And then we have example 4. You're going to split this, right? And we got magnesium and we have SiO3. And we have one of these and one of these. There's no parentheses. Okay, but this is poly, this is mono, this is poly. I have one Mg group and I have one SiO3 group. I do need to pause here because I neglected to tell you that you need to go to page 8 of your notes to see this. So go ahead and go to page 8 and then fill these in, pause as needed. Okay, we're going to finish. We're going to go back up to the top now. We're going to talk about, there are times when we can't use polyatomics and we got to break things down to individual atoms. So we're going to do that next. We're going to say this has Cus, Ns, and Os. This has 1 Cu, 1 N, and 3 Os. 1 Cu, 1 N, and 3 Os. Okay, this one has Cr, S, and O. 2 CRs, 3 S's, because this is going to be distributed through, think of there as a 1 here, so 3, and 12 oxygens, because 4 times 3 is 12. This is going to be the same, no change, because there's no polyatomic. And then here on this one, we have Mg, Si, and O. And we have 1, 1, and 3. So most of the time we're going to be doing polyatomics and treating them as groups, but sometimes we'll have to go down, we won't be able to use the polyatomics. It just speeds it up if we can use polyatomics. If we can't use polyatomics, that usually is because you don't have the same polyatomic on both sides. But sometimes even when you have the same polyatomic on both sides, the problem is more complex and you cannot use them. So you got to just see if you can and hope for the best. I would say 99% of the time, if you have the same polyatomic on both sides, that's going to be the fastest method. However, sometimes we will have to break them down individual atoms like we did here. So either way could be a method for balancing. So now we're on example 6. So example 6, again, we're going to say that we have Mg and Br. We have 1 Mg and 2 Brs, and it would be the same if we were going to break it down to individual atoms. Here we have Ba and PO4. PO4 is a poly, Ba is mono. These were both mono. So I have 3 Bas and 2 PO4 groups. Why? Because the parenthesis says I have 2 of that group. Now if I needed to, I could break this down into individual atoms. And that sometimes, pretty rarely, but sometimes is necessary. I have 3 Bas, I have 2 phosphorus. It's going to be distributed through, think about like an algebra class. And I have 8 oxygens. Here are my 2 units if I'm going to go through and do these as a mono. Think about splitting it, right? I have a lithium monatomic and carbonate poly. This is 2 of these and 1. 2 because of this 2 and 1 because there's no parentheses around the polyatomic. If I had to break it down into individual atoms, my results would be 2, 1, and 3. And then this next example here, we have 2 monos, so all we have is CD and N. So we have 3 and we have 2, and it would be the same because there's no way to break down them because they're already broken down. Okay. So now I would like to go on and do a few more examples. You're going to do some here in just a moment by yourself. So we're going to split this. I'm actually going to switch colors for myself here. And we're going to say that we have francium and chlorine. They're both mono, 1 of each, so it would be the same whether I was breaking it down as polyatomics or not. Example 12, I have sodium and sulfur, 2 sodium, 1 sulfur, and again, no way other to break those down into that. Now, this is our first time introducing a number. This is that coefficient I was telling you about. This means that when I start, I got RB1, BR1, because there's one of each, and then I got to multiply them by whatever number's out in front. So there's 5 here and 5 here now total. So this one's even more complex. Let's start. The best way to start with these is think about starting with the units. Okay, we have 2 CRs and 3 SO4s, 2 and then 3. The 3 out in front says I have to multiply. So that, oops, that's a 3. So that'll be a 6. There's a 3 out in front, so that's 9. Now, I could also break this down into elements, right? So this would be 2 chromiums, 3 sulfurs, that 3 gets distributed through, and 12. That's the base without the 3 in front. And then when there's a 3 in front, and we use these for balancing, we'll talk about that a little bit more tomorrow, you're going to get 6 here, 9 here, and 36 here. Okay, so that's how you do it with the number out in front. This is the number out in front when you're doing it in pieces, polyatomic pieces, but when you have to break it down individual atoms, you have to also be able to do it this way. Okay, let's look at 15. So again, I'm going to break this down first into monos and polys because that's almost always the way we would balance. Sometimes we can't, as I've said, so I have 3 of these because of this 3. I have 7 NO2s, but there's a 2 in front, so then I know that this is going to be 6, and this is going to be 14. Now, if I break it down into individual atoms, I have this compound has manganese, nitrogen, and oxygen, and I'm going to start with the base of what I see without the coefficient, the number in front. So this is going to be 7 and 14. 3 because of the 3, 7 gets distributed through, there's a 1 here, remember, and then 14. So that would be the pieces without multiplying by the coefficient in front. Now I'm going to multiply by the coefficient in front. We get 6, we get 14, and we get 28. Okay. All right, so now we're going to try and split this. We're going to go through the pieces again, Mg and BrO3. So just looking without the coefficient, there's 1 Mg and 2 BrO3s, but the coefficient says to multiply through, so that's 3 and that's 6. Now if I had to break this down into individual atoms, I'd have Mg's, Brs, and Os. I have 1 Mg in the base, I have 2 Brs because that gets distributed through, and I got 6 times 3 times 3 times 3. So this is 3, this is 6, and 6 times 3 is 18. So that's how you would do that. You try 17 through 20, pause the video, try 17 through 20, and I'll go over those in just a moment. Okay, welcome back. So now you're checking your answer. I'll go through these with you. So we have Cu and NO3 to start with it as groups of 1 and 1. 1 NO3 because there's no parentheses, but there's a 2 in front, coefficient of 2. So that makes 2 of these and 2 of these. Now if I broke it down into individual atoms, we have Cu, we have Ns, and we have Os. Thinking about the base without the coefficient, I have 1, 1, and 3 times 2 times 2 times 2 would give me 2, 2, and 6. Going to this one, calcium and phosphorus, there's no polys, so it's 3 and 2 times 3 is 9 because of the 3 out in front, the coefficient is 6. And then going down here, we have MgSiO3. There's 1 and 1, but there's a 1 out in front, so they would stay the same. If I was breaking this down into individual atoms, I have 1 Mg, 1 Si, and 3 Os. Over here, thinking about it in its units, meaning monos and polys, there's 2 of these and 1 of these, but there's a 4 in front, a coefficient of 4, so there's 8 of these and 4 of those. If I were to break this down into individual atoms, sometimes that's necessary, the base is 2, 1, and 4 times 4 times 4 times 4. So this is 8, this is 4, and this is 16. 16. Sorry, that's hard to read. Okay. All right. Reach out if you have any questions.